All right, welcome back here. All right, I'm still in Florida. You guys are still here zipping through the old MSHS hallways, hopefully having a good time. I'm missing you guys. Some of you, figure out who it is. Anyways, touching up on what we did before break, finding the surface area of three-dimensional objects. All right, what we did is we said, let's just draw a net of this. 2 bases, hexagons, 6 lateral sides, all rectangles. And then let's just figure out the area of each individual shape. And then add those 8 numbers together. Not bad. I'm going to introduce something to you called lateral area. You'll be asked on some problems for the next few days to find the lateral area of shapes. All lateral area is, and you might want to make note of this, is the total area of the non-bases. In other words, it's just the sides. Okay? It's taking this and making it simpler. If we were asked to find the lateral area of this hexagonal prism, all we'd have to do is say, well, that's a base, we don't want it. This is a base, we don't want it. And so what we're left with is the non-bases, which are just rectangles. So as long as we can find the area of each rectangle, 6 times 10, 60, 6 times 10, 60, and continue that pattern. Once we get those individual numbers, you have your lateral area. Because all you need to do, lateral area, is 60 times 6, or 60 plus 60 plus 60 plus 60 plus 60 plus 60. So for this particular shape, our lateral area would be 360 square meters. Not bad. And if you think that's not a problem to work with, wait till you get to cylinders here. Cylinders are going to be even slicker than dealing with any kind of prism, because what makes them slicker is the base never changes. It's always a circle. So for the surface area of cylinders, we actually have a nice, neat formula for surface area. We basically are built of 2 squares, okay, and then 1 rectangle. So without getting into too much detail, for surface area of a cylinder, the nice formula, and it's probably in the back of your book somewhere, we would say 2 pi RH plus 2 pi r squared. And again, you can look this up in the back of the book if this looks a little bit scrunched in there. And the lateral area is just like lateral area for a prism. We don't include the bases. So if you think about, hey, this is a surface area, 2 circles in that rectangle, the lateral area is just the rectangular part. Okay. And so our formula for lateral area is also quite simple. We'll say lateral area equals 2 pi RH. And we can use those 2 formulas to come up with the answers to any problem. And I'll tell you from 15 years of experience, students prefer working with our cylinders over prisms just because it is a true plug and chug. You know, if we look at this problem on the bottom and ask to find the surface area and lateral area, all you do, you take those formulas, 2 times pi, our radius is 1, it's half of 2, our height is from cylinder or from circle to circle. So it's kind of weird. A lot of people want to think the height is 2. The height goes from circle to circle. That's the only catch. You know, if we were to stand it up on its base. So our height is 5 plus 2 times pi times the radius squared. And we can literally smash this all into the calculator and it will give us our answer. And the same thing with lateral area. Lateral area, even slicker. 2 times pi times your radius times your height, and it gives you your answer. The only thing with cylinders I need to emphasize is when we talk about height, we're saying if we were to tip this back on its circle, back on one of its circular bases, we could see how tall it is. So hopefully this gives you some hints on how to do the worksheet. You guys are smart, you'll figure it out. Look in the book at examples, YouTube stuff if you need to. Ask each other, you guys are your best resource. So I will see you guys Wednesday with any luck on our traveling. And I'm looking forward to seeing your smiling faces. Peace.